Marc DeTeCt, who will be telling us about impacts in Jupiter and detecting those impacts with amateur data. Marc, are you online?
I am. Can you hear me?
Okay, yes, perfect.
Can you see my screen?
Now we can see you.
Okay, and okay, let me recheck if I'm sharing.
So Marc comes from the Société d'Astronomie de France, and he's an amateur astronomer very much involved in many different collaborations, not only the one that he's going to tell us about today.
Okay.
So now we can see we can see the slides. Perfect.
Perfect. So thank you for introducing me, Ricardo. I'm quite happy to have the opportunity to talk to you about this DeTeCt project aiming at detecting impacts in Jupiter and possibly in Saturn. For detecting impacts, there are actually two kinds of visible effect on the planets. First one, for small bodies, they are like bolide in Earth, and this is the background illustration of Chernobyl that you have behind. And so you have a big flash that is visible from Earth on Jupiter. And the second way is here the very big event we had in 1994, the very first one we've seen in the modern area, where you have such bolides, such big bolides that they are leaving trace in the atmosphere after having burnt in the atmosphere. So the first, so the image that you have seen from 1994 was a professional one, but in 2009 we were surprised by the fact that an amateur, Anthony Wesley, discovered a suspect black streak that you can see at my pointer there at different timing in the atmosphere of Jupiter, and that advanced amateur astronomer was knowledgeable enough to suspect that it was like the 1994 event and a trace of a big bolide which entered into Jupiter. That was exactly the case, and that trace was also observed by HST. You can see the image there. So in 2009, we were surprised, so we thought, okay, maybe that kind of events are more frequent than we can imagine. And we were expecting to see such a kind of an event in 15 years after that 2009 discovery. Actually, it was quite different. What was observed in the next years, so you have here observation made in 8 years, from 2019 to 2017, was flashes that time in the atmosphere of Jupiter. So again, just a bolide burning in the atmosphere. And twice in 2010, 2012, 2016, 2017, from different regions of the world. Asia Pacific, the American continent, or the last two here are from Europe. In following the first flash that was observed in 2010, Ricardo and his team started working on developing a software which could help detecting such flashes in the videos of amateurs. Why that? Because we are many amateurs observing Jupiter. That was already talked about before, and maybe some flashes were not seen live by the amateurs who observed, and then there was really the idea to help the amateurs to detect the flashes like that. The slide before that you have seen were seen live by some amateurs, but nonetheless, more and more users started using the software from Ricardo, which I took over and which was improved really to do more things, and also to be able to help us to estimate the impact frequency just by not only collecting flashes which were detected, but also analysis which proved negative, meaning that there was no flashes detected. Two different methods for detecting these flashes. The first one is really by analyzing the video frame by frame and trying to detect when on the Jupiter surface we could see image, we could see a temporary brightening of some point, which could be a bolide really burning in the atmosphere and provoking a flash. And the second one, so it's really algorithmic, and the second one was a bit more simple, but trying to generate a detection image by just adding all of the maximum value of pixels in a video and removing it from the average pixel in a video to try to show clearly what we call a detection image. So here you have really a flash that is faintly visible here, but in the detection image, it's really more visible. And what we ask the amateur is really to check this detection image, which is generated by the software. It also logs a lot of information, which can help afterwards to understand the quality of the video which was processed, but also to estimate the frequency by logging the exact dates of the observations which were analyzed. And in the years starting 2019, we really had a great success with the software, because we had in 2019 from US the first discovery by DeTeCt of a flash. So the American amateur who observed Jupiter that night had in his processing routine the fact of imaging and in the morning just launching DeTeCt to try to see there is a flash which was detecting, and processing his image to produce a nice image, of course. And he had the surprise to see that a flash was detected by DeTeCt. So it means he missed it live, but DeTeCt really helped him to detect that first flash. In 2021, there was a flash which was observed from Europe by many observers, also in South America, in Brazil, and amateurs were not sure what they did see live. So I was really first in discussion with the one from Brazil. And he ran DeTeCt on it, show something suspect, and contacted me, and we could confirm that what he had seen live and was really not sure that it was a flash was actually a real flash. So here DeTeCt helped, even if it was not the source of the detection. Then 2 years after, in 2021, in October, an amateur from Taiwan, from Japan, amateurs observed also a flash, and one from Taiwan as well. And same thing for the amateur from Taiwan. He could confirm the flash with DeTeCt. He was not so sure about what he observed, but DeTeCt really proved him that it was a flash. And last but not least, that amateur had the good idea of going through all of his old videos, and he discovered that in a previous video, which was shot on August 2020, there was actually a flash that he missed totally, and his video was just sleeping on a hard drive, and using DeTeCt afterwards, he could detect that flash as well. So many data, many flashes. Here you have statistics about how many days of observations, full days of observation, were provided to me for processing and for the analysis. And you see clearly starting a peak in 2019, 2020, 2021 with the 2 flashes that we had, and so on. And we also got a prize for this project. So it's really a lot of observation. For 2022, it's not finished. Some amateurs are still processing their old videos, but it's quite for 2021, for example, it's more than 2 months, day and night of worth of observation. So it's really a very good coverage, which is done. Some figures, I won't go through all of them, but just maybe to signal that we have many participants, 185 participants from 21 countries, that the videos that I got was from more than 3,000, 15,000 videos. So it's quite a lot. And we have data, the project has been running from 10 years. So you understand that I get the result of the analysis. I check them again, doing a second check on the detection images, and then I publish statistics on a web page, which is really regularly updated. And you see there what it looks like. We have everyone which is contributing, which is listed there by order of the number of days of observations which were provided. And this is both for Jupiter and Saturn. And this helps then again to estimate the number of impacts per year. And the estimation out of all of the analysis I got is currently that we are around between 18 and 19 impacts per year on Jupiter, which should happen. This is interesting to cross-check that result with professional work. So you see there something which has been published in a professional paper, and resulting here in the blue square about what should be the frequency of impact per year. And here you have the result of DeTeCt, which is not right at the center for sure, but it's fitting the professional work, which was based on other data or other estimations, let's say. Last thing that we can have from this is not only impact frequency estimation, but with the data of the flash itself, with a light curve. A professional can work and estimate the size of the body, the impact angle, different things. And for the size of the bodies, I wanted just to show you that kind of comparison. So the 94 event, you had bodies around kilometer-sized diameters. For 2009, the trace discovered by Anthony Westlake was more like 500 meters, between 500 meters and 1 kilometer. And for all of the others, it's much smaller. You have many small ones. Let's say everything is is estimated to be between 5 and 16 meter diameter, and actually the last one which were discovered are rather the larger ones. And last slide from me, I wanted really to thank the huge number of participants we have for these projects, all amateurs, sometimes amateur observing in professional facilities like the 1 meter telescope from Pic du Midi, or even sometimes professional. But it's really a huge community that I have a pleasure to work with, and without all of these dedicated amateurs who are spending their time not only on imaging, processing their images, but also analyzing them with the software, we can really get a very good scientific result. I'm really quite happy to enable this with all of these participants, and of course, everyone can join. You do not need to do high resolution images to participate. A flash can be also easily seen on some medium to low resolution images. Thank you. Well, this is my last slide, so I don't know if you have any question before we go to the last presentation.
Thank you very much, Mark. That's been a very good talk. Any questions here in the audience? There's one question there in the back.
Okay.
Actually, I have a question to all the presenters. Mark just triggered that because I saw that in the last slides, some hint on that. I wonder about how the astronomers share their data, or how do you collect that data? Where are those collections? How do you communicate at the data level?
We have a couple of amateur databases, like the French Astronomical Society has one, the British Astronomical Society has one, but maybe I can hand over to you, Ricardo, because for me the main database is clearly the one that you are maintaining. So maybe you can explain it a bit more.
So thanks to the Europlanet project, the previous one, we developed a database that is called PVOL, the Planetary Virtual Observatory and Laboratory. And if you look for that acronym in the internet, you are going to find a database that you can search, and you can find thousands and thousands of images. For the case of impacts, it's a little bit different, because Mark actually receives all of the different files from the observers, not the videos, because that would be hundreds of terabytes. It would be impossible. But he receives the results of the software. The software DeTeCt analyzes the videos and then produces small text files that are analyzed by Mark later, and sun detection images that Mark and sometimes me, we used to look at, because we also get false alerts. Every year there are a number of false alerts that have to be discarded before saying another impact. So there is a lot of hidden work on that, and Mark is the person that is doing all of that hidden work for the most part. And then there are many other databases. There is the ALPO, database from the Association of Lunar and Planetary Observers, and that is the biggest one, but it's more amateur. It's more difficult to look at the data when you are doing big searches. So it's every single different field has its different characteristics, and if you are inside